Welcome to Trikana Skill, your lifetime career partner. Trikana is a pioneer and trailblazer in the field of civil engineering and construction training, seeking to bridge the gap between engineering studies and the construction industry. Slump Cone Test. Conforming to IS Code 1199-1959, 2004. Introduction. What is slump?
Slump is a measure of the consistency and fluidity of fresh concrete. It indicates the workability and flowability of concrete. Slump test. It determines if the fresh concrete has the right consistency for the purpose for which it is being produced. For example, column concrete and beam concrete in buildings should be free-flowing as the reinforcement is dense, and the concrete has to reach all corners and avoid honeycombs. Hence slump will be higher than normal. However, the concrete for a raft foundation needs to be thicker as the reinforcement is not dense and the concrete can flow easily. In case the concrete produced has high workability, then the concrete will segregate at the time of pouring in the raft foundation, which is not desirable. The slump test verifies if the concrete produced has the required workability. This test cannot be used for very dry and very wet concrete.
Some of the recommended values of slump for various types of construction. Apparatus.
Slump cone apparatus made up of a metallic mold in the form of a frustum of a cone with dimensions. Bottom diameter, 20 cm. Top diameter 10 cm. Height 30 cm. End. Weights and weighing devices. Tampering rod, 16 mm in diameter and 600 mm length. Ruler. Tools and containers for mixing ore. Concrete mixer. Procedure for slump cone test.
Dampen the mold and place it on a flat, moist, non-absorbent surface and held firmly in place during filling. Filling of the mold should take place in 3 layers, each approximately 1/3 the volume of the mold. Rod each layer with 25 strokes of the tamping rod. Uniformly distribute the strokes over the cross-section of each layer. In filling and rodding the top layer, heap the concrete above the mold before rodding start. After the top layer has been rodded, strike off the surface of the concrete by means of screening and rolling motion of the tamping rod. Remove the mold immediately from the concrete by raising it carefully in the vertical direction. Raise the mold a distance of 300 mm in 5 ± 2 seconds by a steady upward lift with no lateral or torsional motion. Immediately measure the slump by determining the vertical difference between top of the mold and the displaced original center of the top surface of the specimen. Complete the entire test from the time of the filling through removal of the mold without interruption and complete it within 2½ minute. If a decided falling away or shearing off of concrete from one side or portion of the mass occurs, disregard the test and make a new test on another portion of the sample. If 2 consecutive tests on a sample shows the falling away or shearing off of a portion of concrete, then the concrete lacks necessary plasticity and cohesiveness for the slump test to be applicable. After completion of the test, the sample may be used for casting of the specimens for the future testing. Procedure to measure slump.
Collapse slump. In this case, fresh concrete collapses completely. Mix is too wet or high workability mix. Slump test isn't appropriate for such mix. Shear slump. If 1/2 of the cone slides down in an inclined plane, it is called a shear slump. It is an indication of lack of cohesion of the mix. Again, perform the experiment to avoid shear slump. True slump. Mix has high stiff consistency. In a true slump, concrete just subsides shortly and more or less maintain the mold shape. This type of slump is most desirable. Zero slump. If concrete maintains the actual shape of the mold, it is called zero slump, which represents stiff, consistent, and almost no workability.
Result. In case of a dry sample, slump will be in the range of 25 to 50 millimeters. In case of a wet concrete, the slump may vary from 150 to 175 millimeters.
More about slump. Adjustments to the amount of water in admixtures are commonly required at the construction site. These adjustments aren't necessarily due to poor quality control or material variations alone. At the project sites the concrete is made in large batching plants. There can be a variation between each batch of the mix as well between each of the transit mixers. Variations in slump between trucks can also be the result of other factors such as batching tolerances, aggregate moisture content, concrete temperature, mixing, and delivery, waiting, and unloading times. In any case, the water addition must not increase the water-cement ratio above the maximum permitted by specifications, and the water isn't the only way to adjust the slump. Admixtures and certain additives like silica fumes etc. can come in handy. Thank you for your time. If you have any queries, do not hesitate to contact us.